All right, we're gonna go ahead and get started now. So I'd like to thank everyone who joining us today. Welcome to today's CNCF webinar, the definitive checklist for delivering reliable Kubernetes-based application. So my name is Daniel O. I'm working for Red Hat as a technical marketing major, specialized in cloud-native application development, as well as the Agile and DevOps practice. And also I'm responsible CNCF ambassador, so I will be moderating today's webinar. So we'd like to welcome our awesome presenter today, the Brandon Grove Senior Software Engineer, and Ben Morris, Senior Software Engineer, and lastly, Alex Zhitnitsky, Director of Product Marketing at OverOps. So we have a couple of things for housekeeping item today. So before we get started, so during the webinar, you cannot able to talk as an attendee. So don't worry, there is a Q&A box at the bottom of your screen. So please feel free to drop your question in there, and we will get as many as we can at the end. And this is an official webinar of CNCF. So as such is subject to CNCF conduct of the code of the conduct phase. So do not add, please do not anything to the chat or question that'll be in violation of the code of conduct. So basically, please be respectful for all of your fellow participants and our presenters. So please also note the recording and slides that will be posted later today to the CNCF webinar page at www.cncf.io/webinars. So I'm gonna take you over to our first speakers, Alex. Alex, take it away.
Perfect, thank you, Daniel. So looks like we're ready to start. So hi everyone, thanks for joining us today. We hope that everyone's day is going well, and we're really excited to host our first webinar together with CNCF. So thanks again everyone for joining, and we hope that you'll find the content today useful and your time with us will be productive. So we have a webinar full of actionable advice for you for delivering reliable Kubernetes-based applications. And let's start with the introductions and then just a little bit more information about our panelists today. So my name is Alex Zhitnitsky, and I'm Director of Product Marketing here at OverOps. We joined CNCF earlier this year, and we're really excited to do this webinar today. Now, Brandon, like Daniel mentioned, so Brandon's a software engineer with OverOps, and he has over a decade of experience. So Brandon previously worked on different software applications such as Pentaho data integration, Apache Spark, streaming technologies, and he's also done web development for both government and open source. To his right, we have Ben Morris, who is also a software engineer with OverOps with over 15 years of experience. And Ben gained most of his experience working on enterprise software applications, and he strives to deliver high quality and efficient solutions. All right, so now that we have the introductions out of the way to get things going, maybe actually before that, maybe let's do a quick icebreaker question. Can you guys give a little bit more context about what you do on your day-to-day? Let's start with you, Brandon.
Yes, right now I'm working on a lot of integrations of OverOps into things like Jenkins and Concourse. We have some other ones that Ben's working on, but that's kind of where I'm primarily focused on. I'm also working on authentication and authorization at OverOps.
Perfect, thanks, Brandon. Ben, how about you?
Yeah, my current focus with OverOps is working with source code management system, so that when we do our error analysis of code that we take decompiled code, but we're basically allowing people to take their code directly from a source code management system and view errors in real time when those errors show up.
Perfect. Thanks for the quick intro, guys. So with our next slide, so I'm sure that, well, I think you guys all know this, but so this is a live webinar, so nothing here is pre-recorded. So hopefully there won't be too many issues with the slides, and we also have a couple of hands-on demonstrations, so hopefully everything goes smooth. And like Daniel said in the intro, we'd like to keep this interactive. So if you have any questions, please use the Q&A box inside of Zoom. And yeah, so we'll try to address everything as we go, and we'll have some more time for questions and answers towards the end of the presentation. So yeah, please don't be shy, and we'll try to answer all of your questions. Okay, so let's quickly go over the agenda so everyone knows what's coming. So we're basically going to cover three topics here. So first, we'll spend a little bit of time touching on the results from a recent survey that we ran about the state of software quality. And then Brandon will touch on some of the unique challenges that microservices bring to the table, specifically in the context of Kubernetes. And then together with Ben, they'll both go over this checklist for delivering reliable applications, broken down into 3 phases. Yeah, so with our next slide, so just a few weeks ago, we wrapped up our annual survey with over 600 responses about the state of software quality. And our goal this year was to find out how today's engineering teams are addressing the speed versus quality dilemma. So the full report is available at this link here. So it's bit.ly/overops-survey. And I'm gonna post it in the chat box right now. I hope you guys can see the link. And we actually have an exclusive offer to webinar attendees. So we're raffling a $200 Visa gift card between everyone who downloads it using this link. So the odds are pretty good. So, okay, jumping on to the first stat that we uncovered is, so the good news are that the majority of the survey participants, 70% of them, told us that quality is paramount and they prioritize it over speed. So basically, as kind of our takeaway here was that as applications are becoming more mission critical, it's not just about moving fast and breaking things anymore. So things also need to work, and it's important to prioritize quality. Now, with that being said, the next 2 stats show that a similar percentage of respondents are spending a day per week or more troubleshooting code-related issues. And also over 50% of them, 53%, experience customer impacting issues at least once a month. So although there's a big emphasis on quality, errors still reach production, and developers are spending a lot of their time troubleshooting. Now, to make things even more complicated, so the next stat shows us that 20% are releasing code once or more per day. So, which is what some people might say a little bit crazy. So we're not only talking here about the Facebooks and Googles of the world that are doing this, we're talking about more traditional enterprises like banks and healthcare providers that are now releasing code multiple times per day. And those kind of applications, they really can't afford to break things that often, especially if you're in healthcare or if you're working in a financial services company. Those things impact the bottom line super fast. So these types of companies really need to prioritize quality. And while this survey focused more on the, let's say, realities and challenges of delivering reliable software, so the final stat we'll share with you today before we transition to Brandon is that 45% of these respondents are adopting containers on microservices in one way or another. So while containerized microservices and Kubernetes are really great for delivering software at scale, they also bring in new challenges that need to be addressed. And one way to do that is to take a more structured approach to quality. So Brandon, this was my intro, and I'm transitioning this to you. And just as a reminder, please keep sending questions, and we promise to address them towards the end.
Thank you, Alex. So the first slide that I'm going to be talking about is delivering reliable Kubernetes applications and what those challenges are. Especially with people who are transitioning to a microservices architecture like the last stat showed. A lot of people are having to transition from probably a monolithic type application and get that into a microservices based application thing. And that's just a challenge in and of itself. You're talking about re-architecting code, you're talking about sectioning code off, where do the modules fit in one area, where does the microservice fit over here? How do they need to communicate with each other? How's resilience happen in that way? So those are one of the challenges that you can see when delivering for or just jumping into a microservices type architecture. Also orchestrating deployments and services. If you're running into Kubernetes for the first time, you may be hit pretty hard with, wow, there's these deployments and there's replica sets and there's services. How does this all communicate? Where are the load balancers? How does that all work? It can be a little daunting, and thus we put it as a challenge here. Also, as you're transitioning into Kubernetes, testing effectively is a big thing. So you're going to have to change the way you test and make sure that you feel comfortable with what's being deployed out there. We put polyglot programming in here, and one reason we put this in is because if you are developing microservices, they can be written in many different languages for each different service. So you may have one service that you use that's running Node, and you may have another service that's running Java, in which case it may be hard to go and jump between fixing bugs between services to get things out. So this can be a challenge where you have to wait for another team that may be a little more proficient in a different language than you are to get a fix out there. As you're transitioning into Kubernetes, you also notice that you're going to be sending a lot more transactions between each one of your services, and tracing those transactions through the system can be hard. For instance, if you have an error that pops up in one of your application or one of your microservices, it may not be because of you or that specific service itself. It may be something from 2 services back that called through that generated this issue. And so you have to definitely keep that into consideration, where you have to be looking at all the services that made that full call, that full transaction. And obviously logging is always a big topic of microservices. You don't want to be jumping into pods and checking everybody's individual logging. You want to have probably a little bit better logging, centralized logging place for all of your microservices. So with all that, there's plenty more that we probably could talk about that are challenges. If it's something new, are you scared or confident when you hear Kubernetes or microservices type environment? I'll be the first to say I'd be pretty scared, or I'd be a little bit like, okay, what's the right step to make next? But there may be many of you out there that are also already in this realm and are feeling pretty confident. So with that, we'd like to figure out, like, okay, what kind of cadence? You got this company and you're trying to get into Kubernetes. You know, how do you determine what cadence that you can deliver and feel confident about those deliveries? Well, first I would say you need to examine your business needs in this scenario. So if you're working for NASA, you obviously can't do the get it out fast and break it quickly, because you just can't do that with launching rockets. But if you're Facebook, you're probably more than willing to have errors happen to your users and then fix them quickly and get them out the door, get the new fixes out there. You may be in a company where you're kind of in the middle between all that, you know, maybe a monthly or a weekly release. But you definitely need to examine your business needs. What's the point of getting new releases out there, and what's your tolerance level? And that will help you in determining your release cadence. Also, make sure you research all the available solutions out there. There's plenty of solutions. We're going to go over a few here in the next set of slides of things that help you feel confident when releasing, but there's plenty of stuff out there, and make sure that you're putting the time and money into the things that actually are helping you and making you feel confident about your releases. So I took this test pyramid. It's from Mike Cohn. If you don't know him, he's a big Agile advocate. And kind of just a simple pyramid that near the bottom, you see unit tests, and those are the things that run really fast. And you can run those many times. You can run them on just your laptop, and they'll run really fast. As you start going up into different testing, like integration testing, full end-to-end testing, and there could be many more different types of testing in between all these layers, things are going to be a little slower. May need more resources to accomplish it at a very speedy timing. So if you can, try to write as much as you can in a unit test. If the unit test can solve the problem of making sure that you feel confident with your releases, please write it there. But if not, and there are many cases that are not, you may have to look at releasing or writing tests in the integration level and or the end-to-end test level. So here we're going to go into the 3 phases as Alex showed us already for a continuous reliability checklist. So phase 1, we're going to talk about building and testing. The first thing that, if you're not doing this already, look for some type of static analysis tools that are out there. These are great tools that will run on your code, but it won't run your code. So it'll check your code for industry standards. It can find bugs in areas that you probably wouldn't otherwise know. Things like running multi-processing environments where you may not find edge cases in certain scenarios. Industry standards need to be implemented in certain areas. It's a great start to making yourself feel confident with releasing any code, not just a Kubernetes or microservices type environment. Also, with these static analysis tools, it can identify security vulnerabilities, especially if you have them tied into like a Maven or Gradle, and it's checking to see what kind of dependencies you have. These tools will be able to tell you, hey, there's a new update available for XYZ library, and you should probably pull it in because there's some security vulnerability that's in there that they fixed. And if you're into making sure everybody in your team is writing to the same style, these static analysis tools can also help you with code styling and making sure that your code looks the same so everybody can read it in a nice, clean fashion. The next is unit tests. As you saw on the testing pyramid, these are the type of tests that you want to run fast, right? These aren't integration tests. These tests are the tests that are running tests on the class and the methods within that class. You can make an example that if you're going to test multiple classes, you could be considered an integration test. Or if you're running a test that runs across different modules, that could be more of an integration test. I would argue that unit testing should be really simple to just the unit of code that you're working with in the specific class and method. With all this, I'd also encourage you to make sure that you're testing the right thing. The reason I say this is there's a lot of statistics out there that, hey, you need to run 80% test coverage or 90% test coverage on all of your code. I would argue that that's not the right thing to do. We need to make sure that we're testing the right pieces of code. Just because you tested a whole bunch of getters and setters doesn't mean you did good unit testing. And so make sure that you're testing the right thing at the right place. And there's integration and end-to-end testing. And this is kind of where that fits in the top of that testing pyramid. And there's a lot of things in between and all the way through just regular integration testing to services testing to full end-to-end testing for a user. But these things can be testing individual components, components to components, user testing, and could be handling business use cases. There could be even API testing where you're looking at things like JMeter as an open source product to then be used to test all of your APIs that your developers may be using as a user. So consider those things, and all three of these should help in your confidence level. So I'm going to go ahead and exit out of this and run through a little demo. What I'm going to show you is just some simple static analysis tools and showing some stuff that you can do at just a very simple level to make sure that you're confident in what you're releasing. So the first thing I'm going to show is right now we have this client service right here, and it's something that we're going to release to a Kubernetes type environment. And so you usually develop a YAML file and you want to do a kubectl deploy and send it out there. But first thing you can do is you can always make sure that, is this YAML file appropriate? Is there any mistakes inside of this? So I'm going to go ahead and run here as a kubectl apply with a validation and a dry run. And with that, you can then give it your file, and then it will check just to make sure that, hey, is this YAML file even correct? Is there a mistake? Is there a typo in this piece? I'm gonna go ahead and run this, and oh my goodness, yeah, there is. There's actually a typo here. And if you can take a look, let's see, oh, I spelled metadatas wrong. It should have just been metadata, not metadatas. So let's go ahead and check that out. And then I'm going to write this file back. And then, bam, everything looks good. But this is just a very simple thing, especially in a Kubernetes environment, that you can check this in on Git commit hooks or any other type of code repository software that you're using to just make sure that this is working. Maybe even, you know, pull requests if you're using GitLab or GitHub in this scenario. The next I'd like to show is Sonar, which is a static analysis tool that looks at your code and determines if there's anything awry without actually running it. So I pulled in the famous Mockito. If you ever did Java unit testing, a lot of people use Mockito to mock things out. And I was like, you know what, I'm just gonna run this and just see how many errors there are. Right now that looks like they found 27 bugs, you know, 1 vulnerability, how many days of debt that would be. And running this right now, I did not do any tweaks to Sonar. I pulled down their open source software and just ran it on Mockito just to see what it would tell us. So I'm going to go ahead and click on bugs here, and I'm going to scroll down because I had a couple in mind that I wanted to show you. But you can see here, if you ever used optionals recently, there was no is present check here, so they just got the object directly without checking if it's present. So if there's a problem here, if this is null, you're going to be throwing exceptions everywhere. So it may be a good idea to check if is present and then do like an or else and return something different. But there could be many other things that are in here that, you know, maybe this is appropriate. You know, maybe whatever we have in this loop right here, that's how we want it to run. In which case you can go ahead and select in here and say, hey, this is a false positive, or that maybe you fixed it, or maybe say, we're not going to fix this at all. But it's a great tool to use in your daily coding environment. And this thing will run without you having to do anything once you have it set up and working initially. Let's go back to my presentation. And from that, I'm going to hand it over to Ben to lead us into phase 2.
Thank you, Brandon and Alex. So the next item we have on our checklist is related to the staging environment. So you can go to next. There you go. So performance and scale testing. The question is, how is your application's performance and its ability to scale? So we have our staging environment. Our staging environment should replicate your production environment as closely as possible, so that when you execute your performance and scale testing, you can be confident that it will behave the same as it will once it reaches your production environment. So performance testing will determine whether your software meets speed, scalability, and stability requirements under expected workloads. And there are a handful of different types of performance testings that you can do. The first is load testing, which determines your application's ability to handle expected user loads. And the objective of this test is to identify where there may be potential performance bottlenecks. The next is stress testing, which is determining your application's ability to handle extreme workloads. The objective of the stress test is to find where your application's breaking point is. Additionally, you have endurance testing, so determining your application's ability to handle load over a long period of time. It may perform well in the beginning, but after running for some period of time, you may have performance degradation. And then we have spike testing, so determining what your application's ability is to handle a large spike of user load in an instant. And we have volume testing, so determining if your application performs depending on how full your databases are. Sometimes, it operates very, very well under small amounts of data in your database, but once you add a lot of data, it stops performing. And then, of course, there's the scalability testing, determining your application's ability to effectively scale up to support an increased user load. And this helps you effectively plan for capacity additions to your system, which helps, from both the technology side and from the business side. We have the browser response timing, which tools like Selenium, which you can use in your automated testing, will test things from everything from like user testing to end-to-end testing, and you can use those tools as well to test browser response timing. So some amount of these performance and scale testing you may want to do kind of in your CI/CD pipeline, but some of them, like the endurance testing, probably requires a much longer period of time, so it may not fit. Those may be like ancillary tests to this, but things that are still important to do. Regardless of the tests you do run, it's important to take these results of the test that you run and store them somewhere so that on subsequent runs, you can compare those results, and that will play into your go, no go decision for going to production. All right, next, Brandon. So as a business organization, it's important for you to understand your error tolerance level for a release. So Brandon kind of mentioned this before, you know, if you're launching rockets into space, your error tolerance is probably a little different from, you know, a company like you said, Facebook, who wants to just get features out as quickly as possible. If you're launching rockets, you probably need to be pretty sure that your software is going to not fail when you're launching those rockets. So talk a little bit about dashboarding. So dashboarding is a really effective tool for gathering and viewing metrics as you're doing your builds and as you're doing your testing. That way you can get kind of a bird's eye view of all of the issues that you may have, or, you know, places that you need to improve. There's a lot of different dashboarding products out there, like Grafana, Kibana, or Prometheus. They're all open source, and they're you know, great tools to use for dashboarding. Additionally, it's important to know what your rollback strategy is. Can you roll back quickly? You know, even in the best scenarios, when things seem to have gone very well, you may get to production, and then you have the need to roll back. You need to understand what that is before you get into production. Next. All right, so now that we've gone through all these things, we've done our static analysis, our unit tests, integration tests, end-to-end tests, performance tests. Now, where is your confidence? Next. Which brings us to phase 3, production. So after you're satisfied with your staging environment, we'll go into production. This can either be done depending on how you operate in a manual or an automated process, and that depends on your business needs. And you need to look at what is your rollout strategy. So one of the advantages of Kubernetes is that you can have multiple teams working on different modules in your application, and those modules can be developed and they can be deployed separately, or they can be developed together, or developed and deployed together. However, one of the challenges of Kubernetes, cloud native applications, is that ramping up the speed of those deployment times can have various issues and benefits. So some of the benefits are you have more rapid development, so there's more features in the hands of your customers, and you can get feedback very quickly. However, with more releases, the more you're doing that, there is the higher chance of negatively impacting your customer's experience. So there's a handful of release strategies that we can employ when we're releasing Kubernetes applications. I'm going to talk about a couple right now. So kind of the default of Kubernetes is to do a rolling update, which essentially, you know, takes each pod, updates it with the new code, and then once it reports back to the system that it's ready, it will take down the old pods and kind of go from there. The other one is kind of these canary deployments. It's a progressive delivery used to roll out changes to a small subset of users before introducing the changes to everybody. And some common strategies are to release these features to maybe a random subset of users, possibly internal users, or some other set of users based on a demographic. And once your features have been released and you feel comfortable with their stability, you can roll out the changes to the rest of the system. While canary deployments can be done entirely inside of Kubernetes resources, it's much easier to implement using a service mesh, something like Istio, which can regulate which users are routed to where and when. Additionally, we've worked with some CI/CD tools that offer support for facilitating canary deployments with Kubernetes. The next question is, when should you be doing builds? You know what your deployment strategy is, when should you be doing them? Again, this is business decision. If I have a lot of traffic, in the middle of the day, probably shouldn't be doing my release in the middle of the day. It's best to find the time that you can risk, having some downtime. You're not going to worry about spikes when you want to do those releases. Also, if you want to make updates to your system, you got to make sure that you're updating them in the correct order so that you're not breaking other, services that may be using an API while you're doing that build. All right, next. All right, and then the next question is, have you established a feedback loop? So what do I mean by a feedback loop? The feedback loop is the ability to notify when there are issues anywhere along this development cycle, whether that's in development and testing, building, staging, or production. This feedback loop can be done using a myriad of tools that can aid in APMs. We have logging, we have runtime code analysis. Lots of these tools, very common for them to integrate with issue tracking and incident management software, so that if something does happen during the build phase or during test, or even when it gets into production, that feedback quickly goes back to the product and engineering teams that allows them to make the best decision on how to move forward. Also definitely helps in production if you have a good feedback loop there, so you can kind of mitigate some of the risks for your customers and get issues fixed as quickly as possible. Now, I guess you can go to the next slide. So it's important to remember that even with the proper static analysis, unit tests, integration tests, end-to-end testing, performance and scale testing, your code can still break. But with a good system in place, you can mitigate those risks when and if the code does break. Next. So with that, I'm going to turn the presentation back over to Brandon. He's going to give us another demo.
Yeah, so I'm going to demo a little bit here of some of the stuff that we do at OverOps. And so let me pull up this really quick. So this is Grafana. Many of you have used it. We talked about it, Ben talked about it for a brief moment, is using this as a means of looking at your whole system and making sure that you're ready to go to the next stage. Maybe you're ready to go to a full deployment in Kubernetes. This could also be used in saying, oh no, something's happening to our system. We need to do a quick rollback in this area. And so Grafana is a great tool for doing that. We have a couple dashboards that we've customly created for us. So I'm going to click on a few of them. As you can see, we have things like a reliability score and tracing transactions and some throughput that we have on our system. So it's a great way for somebody to get a high level look on what's the health of everything going on. I'm gonna go back here really quick. And I'm gonna show just a brief little system of what we've done. As you can see, we've had some errors here that have popped up and we're trying to figure out what those are. But if we go ahead and click on these links that we populated in Grafana, you notice that we'll bring up OverOps, and this is where OverOps comes into play of helping out in runtime analysis. We have a complete code stack here, decompiled code that's run in Java, and we notice that we have some exception that's running. So we have a SQL transient connection exception that happened on this line of code. And as you can see, I can kind of hover over each one of these variables and see what those were and how it was called through the call stack. So it's a very useful tool, especially for things that are running in live environments. And this is where we can get our feedback loop and making sure that our software is being delivered and is running appropriately in a live system. This OverOps tool can also be used in any plethora of the full phases. So with that, I just wanted to go through a review really quick. That we had the phase one talking about stack analysis, things that can look at your code without even running it. Make sure you're running unit tests. Make sure you're writing the right unit tests to test the right things. If you need to use integration tests and end-to-end tests in certain areas, that's fine. Just make sure you know they're going to run slower, or you're going to have to spend more money and resources to get them to run faster. Make sure you're testing performance and scale with all of your microservices, and making sure that when you're ready to go into staging go, no-go decisions, that you have an ability to roll back or quickly roll forward into the next thing. And that's what kind of leads into phase three with, having your build rolled out. Do you want to have canary builds? Do you want to have just a regular rollout where we do one pod at a time or one microservices at a time? And lastly, make sure you have a feedback loop that's always running, not just in phase three, but on all three phases. So this, I'll give it back to Alex.
Perfect. Thanks, Brandon. That was a really great overview, guys. I like how you structured it and kind of broken it down into steps. So I hope this was helpful for everyone to wrap their mind around the topic and helping you guys deliver more reliable applications. So before we jump into the questions, just a quick reminder. So we have this exclusive opportunity here for attendees only. So anyone who downloads this survey report that we covered the results of in the beginning will enter into a $200 Visa gift card raffle. I just shared the link here again in the chat. So yeah, actually, Brandon, Ben, and I were talking about it yesterday, and so the odds seem pretty great. And yeah, and of course, the survey itself also has really good insights about the state of software quality. So cool. So that's it for today, and huge thanks to our panelists. So with the questions, let's see what we have for the questions. Let's see, Brandon, we have one for you. So let's see, is there any other tool other than the dry run option, which can be used for Kubernetes-based linting?
Yeah, there's an open source tool that's out there called TerraTest that can test some of these things as well, and also test that the deployments are going out. I would check that out. There's also Kubernetes-based, if I remember that one correctly, that can do some linting type tests in that scenario. There's probably plenty more out there that I'm not aware of, but I'm sure you can find some as you do your research.
Thanks, Brandon. There were a few questions that we kind of answered on chat. So first, so yeah, the slides and the recording, they'll all be available on cncf.io/webinars. They'll be available later today. There was another question about Grafana, actually. So if it's a customized Grafana theme or is it just a dark theme? So yeah, it's Grafana's default dark theme. Another question about CI/CD tools that can be used to do canary deployments in Kubernetes. So there are many tools out there. So one of them is actually GitLab CI/CD. So many people know them for their code repository, but they also have CI/CD pipeline tool that has support for canary deployments. Let's see if we have any other questions. So, all right. So this question, so to either Ben or Brandon. So where do you store the test data from a performance run to compare with subsequent tests? And what do you use to compare the results?
You know, to be honest, when I've done this before, we've just kind of written our own stuff to store that in a database and then write our own scripts that do the testing. I'm sure there are plenty of tools out there to do it, but I haven't actually used like a specific tool to do those things.
Got it. Okay. Thanks, Ben. We have a couple more questions. So, oh, that's an interesting one. So tests are fine in development, test, and QA, but we get problems in production environment. So who should we blame, our code or the tests?
I think that falls in line with Ben's. The last thing is things are still going to break, right? Obviously, if we had all the money in the world or all the time in the world, we'd be able to test everything and make sure it was perfect getting out. I try not to think of who to blame, but I tend to think of how quickly can we get things back up and running, right? And so that kind of falls into the rollback and roll forward, or go into the next release as quickly as possible if you're able. But there are ways to mitigate that, and I think Ben hit one up where you want to try to have a QA system or a system that's much like your production to do that. There's also tools that you can look at where you can do deployments that are out there, and they do things called mirror or shadowing transactions. And what that means is you may get like a API call into your system, and it will still go through the normal path of your current deployment that's out there, but it will make a mirror transaction to some of your pods or some of your microservices that are out there that are running the new code. Now that code will never see the light of day for a user, but then you can also test that to make sure that you can handle some load and some performance testing and kind of be out there almost on the verge of ready to make the switch over to a go, no go decision.
Perfect, thanks, Brandon. We have a few more questions. So let's go with how do you draw the line around end-to-end tests? Where really are the ends in a large, complex system?
Yeah, I think this is another one of those kind of subjective, type of questions. We have anything from, we want to test, end-to-end business cases versus just, let's click every button, make sure we exercise every, API when we run our end-to-end tests. I think it just depends on, what do you feel as a business are, kind of the high priority items and things to test when you're doing your end-to-end tests. But I would say, determining what an end-to-end test really is, it's going everywhere from the front end all the way through through the back end and hitting multiple services along the way. We talked a little bit about integration testing, which can test one or more components, but may not be like a full end-to-end test. So I think let's see, where are the ends of the large complex system? So yeah, I guess that's the thing. What is the last piece you need to hit? I'd say in most cases probably something like a database, but it could be data storage or some other API calls you're making to a third-party system. So again, it's kind of subjective thing to define.
Perfect. Thanks, Ben, for this answer. 2 more questions. So in general, what is the DevOps tool chain your company is using or promoting for end-to-end automation of a loop or feedback loop from product stories to build, test, promote? And yeah.
So right now, our company, as for feedback loop, we work really closely with the sales team, and we're also working very closely to product management to tell us what the customers are. I'm a developer, and so has Ben. So we get a lot of our feedback from there, who are interfacing with the customers, because we have to spend time writing the code in means of that feedback loop. Also, as you can see, some of the stuff, the tools that I just showed you at the end, that's also a feedback loop to us that maybe something isn't working right. You may have a threshold that we're willing to have a certain number of errors that happen in our system, and that's fine. But if you start seeing it spike from that normal error rate to something else, that's a really good feedback loop for us to go, hey, we need to go in there and we need to fix something, or we need to roll back because we're just not sure what exactly happened. So was there another part to that question, or did I cover it?
Yes, exactly. That's why I kind of stopped. So there are 2 parts to this question. So this was the first part. And now the second part is how do you integrate tracing into a CI/CD process? And there was a follow-up question there if we're using something like Jaeger or Open Tracing for containerized and just distributed applications.
Yeah, I mean, I think they brought it up, like Jaeger's one that you can use, and Zipkin is one of the other ones that you can use that are out there in the open. I'm sure there's, like I said, many more that are out there, but they definitely look at the tools and research them. One thing I like to do is just run a little test application with that new piece of software and see what it does. A lot of the software that's out nowadays is usually freemium or open source, so you can at least test it out and see how it works. And if that helps, it's great. If it doesn't, then look at another tool that may be a little bit more beneficial. But definitely do your research and determining where you want to spend your time and money on. So.
Perfect. Thanks, Brandon. All right. So that's all the questions. These are all the questions we have today. So yeah, huge thanks to you guys, Brandon and Ben, and Daniel, for helping us today. So and thanks everyone tuning in. Don't forget to use this link to download the survey. And if you'd like to learn more about OverOps, you can check us out on overops.com and sign up for a live demo. So yeah, thanks so much, everyone. And Daniel, kicking this off, back to you.
All right, that's really awesome. Thanks, Alex, Brandon, and Ben for the great presentation and such a great demo today. All right, that's all the questions we have time for today. And once again, thanks for joining us today. And also, as I mentioned earlier, the webinar recording and slides there will be online later today. So we are looking forward to seeing you at our future CNCF webinar again, and have a good rest of the day.
Thank you.